Hello, let's take a look at this loan amortization question. It says, assume you have taken out a 25-year loan of $177,290 with an annual interest rate of 6.75% compounded monthly. Part A says, determine the payment amount in dollars to the nearest cent on the given loan amount. And part B says determine the outstanding balance in dollars to the nearest dollar after 18 years. Okay, so part A wants us to determine the payment amount, which means they want you to figure out the amount that you would pay at the end of every month for the duration of the loan period, which in this case is 25 years. So this is a loan amortization question. So amortize a loan means to pay a loan off with regular payments, usually over a predetermined period of time. So in this case, in part A, they want us to figure out what that payment amount would be, what the amount that would pay at the end of every month. Um, there are two ways to do it. The fast way, and usually what would be expected of you, would be to solve it using the TVM solver, which you would usually find this in most TI systems. So your TI 83, 84, 89, which is not as common these days, and also the TI Inspire. And another way you can do it, for those who do not have a TI calculator, is just to use the formula for the present value of an ordinary annuity. When we say an annuity is ordinary, it means that the payments are made at the end of each period. So you pay at the end of the month and then the next period and you pay at the end of the month. If you were to pay at the start of the month, then that would be an annuity due and the formula would be slightly different. Um, in most cases, when you encounter amortization questions, they'll expect you do it. Well, it's assumed that it's an ordinary annuity unless otherwise stated. Just assume that this is the case. And there are a few variables to consider. The first one would be N. So in this case, N stands for the number of payments that are made for the duration of the loan. Most often you can say uppercase n is gotten by multiplying the lowercase n by t, where lowercase n stands for the number of payments that are made each year. So in this case, that would be 12, and t is the loan duration, or the amount of time over which it should be paid, which is 25. If you multiply those two, then you would get 300. So using the TVM solver, in the TVM solver formula, N would be 300. Interest rate would be 6.75%. A cool thing about the TVM solver is that you do not have to convert your interest rate to a percent amount or to a decimal. You can leave it that way. It's factored into the formula with the interest rate that's with the like percent formula that you have. So just put in the regular percent and it would compute it properly. The present value is the amount that you owe today, like the principal of the loan that's currently owed, which in this case would be 177,290. Most of them with loans, they'll expect some kind of down payment, and you would subtract the down payment from whatever the cost of the item would be, let's say a home or a car, and then that would be the present value. But in this case, the entire value here is your present value. The PMT, or the payment, is what we're looking for. The future value would usually be zero because we want to pay down the total value of the loan at the end of 25 years. So we want that to be zero. The payments per year is 12 because we're told actually, technically, what we're told is the number of times is compounded. It's compounded 12 times. And the payments per year and compoundings per year would usually be the same. So you plug all of those into a TI-84 and it would give you the answer like really nicely. So I'll pull up a calculator, an emulator that I have. I'll turn it on. Okay. Um, I'll come out of there and just show you how to access it. If you're unsure, you go to apps and finance. And the very first one is your TVM solver. So the number of payments we have was 300. There are 300 payments. The interest rate is 6.75%. So no need to convert that to a decimal. If you do, the answer would be wrong. The present value is 177,290. The payment is what we're trying to find. I'll skip that for now. Whatever you're looking for, you can just skip around. Don't put a zero in there or don't clear out everything, because if you do, it will it would give you some kind of error. So if you do clear, it will not let you move up or down. So at least put something there. Future value, we want that to be zero. Payments per year and compoundings per year are the same. It's an ordinary annuity, so PMT should be end. So I'll go back up to the monthly payment and solve. So the solve is kind of lime green, so I'll do alpha to let me access that menu and then enter. And that gives me the value. So like that, quick and easy, the amount you would have to pay at the end of every month is $1,224. And let's figure out the decimal. Let's say 92. So 92. Because the first part said to the nearest cent. So 0.92. So that's how much we'll pay. For part two or part B, they want us to determine the outstanding balance after 18 years. Um, Let me mention a typical mistake I see before I solve it the proper way. Most often what I see some people do is, okay, so you correctly determine that the amount you pay at the end of every month is $1,294. And you would, since you have 300 of these, so you multiply this by 300 to get a certain value. So we let's pull that up. 992 1.92 times 300. And so we get 367,476. So this is how much you would pay if you took out a $178,000 loan. You pay approximately that. Just a lot in interest. And over 18 years, paying that amount every month, the number of payments that would be made would be 12 times 18, which should be 216. And so the amount that would be paid, or that would have been paid over 18 years would be 264,582 and 72 cents. So you would assume that the amount that you have left over would be the difference in those two numbers, which in this case would be $102,893.28. But if you do that, your answer would be incorrect. And the catch here is this amount includes your balance on the principal and the interest that would be paid over the 7 years that are left over. But the question is not asking you to find the balance and interest. They want the balance only. So how do we find the balance? So they're saying once you go past year 18, how do you figure out what you owe? What you owe after year 18 is the present value. So you're technically looking for the present value, and everything else would remain the same. Actually, another thing that would be different is N. So how many payments would we have left from that point? Well, so we have 12 payments a year and we'd have 7 years left. So this should be 84 payments. So this would also be different and everything else would remain the same. We also determined the monthly payment, so we'll leave that in. And please leave it as negative. Don't be alarmed by the negative sign. It just means it's money that leaves your account, money that you pay out. Whenever money value is positive, it means it's money that you receive. As with the present value, you received a loan of 177,290. And with the payment, the PMT, you pay out a $1,224.92. So that value is negative. And so let's do that and compute the new present value. So let's go to the TVM solver. I'll change N to 84. Interest rate remains the same. The payment remains the same. I'll leave it with the decimal. Although a lot of times you might just want to put a 2 there and then delete everything. Because this is technically what you would be paying and not the entire decimal. And then we'll go back up to present value and solve. So the amount that's owed after paying that amount for 18 years would be $81,820.81. Painful, right? No, I don't know about you, but that seems like a lot after paying for 18 years. But yeah, and that's because a huge chunk of the payment actually went towards interest. So that's the balance on the initial loan amount of 177,290. So that's the balance section of this. So 81820 and 81 cents. And if we were to figure out how much in interest, we'll simply subtract that from um we'll subtract that from $102, 893 and 22 cents. So let me compute that quickly. And so the amount in interest that'd be paid over the 7 years left would be 21,072 and 47 cents. So yeah. And the answer to part B would technically be 81,821, since the question says we should round to the nearest dollar. So yeah, so that's how you would do this kind of question, at least using the TVM solver. So now onto the second part that I mentioned, as in doing it the longer way. If you do not have a TI-84, then you can always solve it using the formula of an ordinary annuity. So we're looking for the present value of an ordinary annuity. An annuity is ordinary if we're making the payments at the end of each period. It would be an annuity due if we paid at the start of the period. Okay. Um, all the symbols mean exactly the same thing. The only thing that's different is I, which we haven't found yet. I stands for the interest rate for each compounding period. And we solve for that by dividing R, which is the yearly interest rate, by the number of compoundings per year. So for this question, R would be 0.0675 and N is 12. And this is another thing, because we're not using the TVM solver, your interest rate would have to be converted to a decimal. So when we divide these, we get 0.005625. And then we can rearrange the formula to get whatever we need. So for instance, in part A, we're looking for the payment. So to find the payment, I'll divide both sides by the ugly chunk, I might say. So it would be the present value of the ordinary annuity divided by 1 minus 1 plus I to the power negative n divided by I. So this would be 177,290 divided by 1 minus 1 plus 0.005625 to the power negative 300 divided by 0.005625. And if you plug all of this in, you should get exactly the same thing. However, it would be positive this time. So this would be $1,224.92. And if we're looking for the outstanding balance, then we'll be we would solve for the present value. The payment remains the same. 1 minus 1 plus 0.005625 to the power negative 84 divided by 0.005625. And if you plug this in your calculator, you should get 81,820 and some change, which should approximately be 81,821, which gives us the same answer. Under certain circumstances, it might be, well, it usually is more efficient to solve this using CVM solver. But if you don't, then you can always use the formula and you get the same answer. I hope this helps clarify things for you. And feel free to leave any questions and comments that you have. Thank you. Bye.